Hello friends, but just look at this impressive exercise we have here. I had to enlarge the figure so it can be well visualized what we're going to do in this exercise. As always, you can solve it in your notebook and leave me your answer in the comments. We have here a circle of radius 4 meters and a circle of radius 2 meters. And we're asked to find the shaded blue area that we have over here. We're going to erase it for a moment since we know what we need to find. Let's erase it to see how the exercise is done. Acima desse opus from here, from the center of the circle to any part of the perimeter of the circle. Let's say it measures radius. I'm first going to draw a line downwards and say this is radius. Then here, in this part, if we draw a straight line up to here, notice this straight line isn't coming out very straight, no. This straight line up to this one, because this measure here must also be r, because well it's the same distance from here to here. Now what are we going to do? We are going to cross this line, which is the radius. We are going to continue it down here, notice up to here. Aponam apya yapte, and then we're going to draw from the center of the large circle to the center of the small circle. Another line, pay attention to straight konako state key. Okay, pay attention like this. And what has formed is, we've got ourselves a right angle triangle.
90 degrees.
So many lines.
Here.
This is the chapter. See if everything from here to the circle's perimeter measures 4 meters. Because that's the radius. Then this little part here, which is the cathetus, measures 4 minus this little part here that measures radius. Fantastic, we already have one leg. Now what will Nicodemus tell me? If from here to here is the perimeter of the big circle measures 4 AC, and if we add this little part here, which we had said is going to be then to capacita, then the entire hypotenuse is 4 plus E. Fantastic. We have the hypotenuse and we have one side and we can determine that side from here. With Pythagoras, then Pythagoras tells us that one side squared in circle 2 is going to be equal to the hypotenuse squared minus the other cathetus.
Squared.
So A is what we are looking for, therefore it's going to be this leg here. We'll call it A. And this leg here will then be B.
Over here.
So then, A squared will be equal to the hypotenuse squared. What's the hypotenuse? 4 plus 0. We'll put 4 more r's here, squared.
Thank you.
And
You're
squared,
welcome.
what is base? 4 minus r. 4 minus r. Sorry for this, I drew a line 4 minus r and this is also squared. Very well. We have two binomials squared. And this one here and this one here that we are going to solve. A squared binomial is
First term squared.
4 plus twice the product of the first term, that is times 4 finished close plus the square of the second term. We see this one less and open parentheses and develop this squared binomial. First term squared minus twice the product of the first term, which is 4. By the second term, which is r, and plus the second term squared, r squared. Alright, let's continue over here. We have a squared equals,
See you next time.
4 squared is 16 plus 2 times 4r is 8r plus r squared. And then we apply the distributive property with this sign to everything inside the parentheses. Minus by plus gives me minus 4 squared is 16. Minus by minus gives me plus 2 times 4. R is 8r. Then I have negative times positive, which is negative r squared. Very well. We have that squared is going to be equal to 16 over here. We're going to start eliminating. I have 16 positive, 16 negative. I have r squared positive and r squared negative, which left us 8r plus 8r, that is 16r. Okay, we have to square it. Well, now we're going to apply the square root on both sides of the equation. We're not going to apply the properties of absolute values here because we only need the positive value. So here this 2 simplifies with the index in the root and we're left with como simple path. On the right side we have the square root of 16, which is 4, And inside we get the square root. Inside the root we have r, and we found the leg we were hoping for, which is this side here. Let's erase this from here and let's put what it equals. It equals 4 times the square root of r. 4 times the square root of r. Alright, now we're going to erase this here to keep going. Ready. And now then we're going to continue over here. Notice I'm going to keep drawing this line that I traced here horizontally. I'm going to extend it further. That's notice so this here will also be a mistake because it's the same distance, this one and this one here. And we'll also join from the top down to here. Very well. And we are going to draw a line from here to here. And we have another right triangle again. How long is this side here? Well, if all this measures 2 meters because it is the radius of this circle, so this part here will be 2 minus this section, that is r, 2 minus r. Fantastic. And how long is the hypotenuse? Take a look from here to here. It measures 2. And from here to here measures r. So the whole hypotenuse measures 2 plus r. And again, we have what we had here. We need to find this side over here. Let's apply the same that we apply, not Pythagoras. Then we have to square or make equal. Now let's speed up a bit since we know what we need to do. Then we have that a squared will be equal to the hypotenuse squared. The hypotenuse is 2 plus r. 2 plus r squared plus, minus b squared. What is b? It's this side right here. Squared 2 minus r. We have 2 binomials squared that we're going to solve. The first term squared, 2 squared, plus twice the product of the first 2 times the second term times r. Therefore, sinat and poesie plus the square of the second term minus open parentheses and solve this binomial. The first term squared term minus twice the product of the first term, which is 2 times the second term, which is r plus the second term squared. Fantastic. Now we have here that squared will be equal to squared is 4 plus 2 times. 2 times r is 4r. Plus r squared we've got here, and apply the distributive property with this minus, which is going to change all the signs. Less for more is less, and 2 squared is 4. Less by less, is it bad? And 2 times r gives me 4r. And minus times plus is minus r squared. Alright, we have that a squared is going to be equal. We have positive 4 here, negative 4 here, r positive here, r negative there, r squared. We have 4 more 4. That gives us 8. Very well, we apply the square root on both sides of the equation in this way. Ready? And on this side, we simplify 2 with the index in the root. And we are left with, on the right side, we can write this 8 as 4 times 2 times r. Ready? We have a equals. This 4 can come out of the root as the square root of 4 is 2. And inside the root, we have this here. We are up to 0. Very well. And now we have then the side, the catetus we were hoping for impressive. We have quickly found this catetus here. It's 2 square root of 2r. Great, let's erase this part here so we can keep going. Alright, I've erased it. So if we're going to continue, over here we can draw a line from the center of the large circle to here, to the perimeter of the small circle. Notice a straight line is drawn. And it comes right here to Kasi, to the highest part of this medium circle, then we can draw a line from the center of the big circle to the center of the small circle, like this. That's how it is. Alright. And once again, we have right triangle. This side measures 2 meters. And that hypotenuse, how much will that hypotenuse measure? From here to here, look cool. And from here to here measures 2 because it is the radius of the small one and the radius of the big one. So the entire hypotenuse measures 6. 2 plus 4, that is 6. Done. And how much will this side up here tell me? It's easy to know, I have it here. 4 times the square root of r, which is the distance from here to here. And then the distance from here to there is 2 times the square root of 2a. So I just have to add these two. I have 4 square roots of r plus 2 square roots of 12a. That is the distance of this eastern catheter. Once we have all the catheti, we can find r using Pythagoras. Let's do it. So we have 2. The square of the hypotenuse will be equal to the sum of the squares of the other two sides. Very well, how much is the hypotenuse? The hypotenuse is 6. What remains is 6 squared equal what is side A? Well, it can be either of these two. I'm going to say it's this dialogue. So you have 2 squared plus B squared. So if this is A, this must be B. We note here 4 times the square root of r plus 2 times the square root of 2r. All this then is squared. Very well. 6 squared is 36 and this will be equal to 4. But here is a binomial squared. We will apply it. Then the first term squared. I get 4 square root of r squared. The first product doubled by the second. This is the first
4th root of r. For the second
which is 2
term.
times the square root of 2r plus the second term squared. Inan siya 4 si de porque siya with square root. This is the second term squared de. Iso mat protestiyar tetet. We have then 36 equals 4 plus 4 squared, which is 16. Who's patent kidep kamas sintesikit. And that's and the square root of r squared gives me what I have inside the root. Because the index is eliminated with this exponent and I am left with just e. Plus times 4 is 8 and times 2 is 16. And over here we have r times square root of 2 times square root of r. We can write this in the following way. The square root of r will be left as the square root of r. This square root of 2 by the square root of r. Let's write it like this. Square root of 2 by square root of r, done. Is in the senante a plus this squared. 2 squared is 4. And this root cancels with this exponent, leaving us simply with 2c. Then we have 36 equals 4 plus 16r. 16r plus over here, notice I have r and r square root of r is r3. Then possess this. So we get 16 times the square root of 2 and times L. Plus 4 times 2, which would be 8 of r. Okay, then let's continue over here. We left everything with an r on the left side and the numbers on the right side. We get 36 and this 4 goes on the other side as minus 4. And that is going to be equal. Notice I have 8r over here and 16r over here. That gives us a total of 24r. More. I have here 16 times the square root of 2r. Fantastic. So over here we can make it this, okay. To continue, right? We have 36 minus 4, which is 32. And that equals, we can factor out an 8 here. And if we divide 24r by 8, it gives us 13. See you, 16 divided by 8 gives us 2. Square root of 2 is 1.414. We've taken out a common factor here, the order, to be able to pass it to the other side to divide. So we have 32 divided by 8. And this is going to be equal. 3.5 pass 3r plus 2 square root of 2r. So here then 32 divided by 8, that is 4. Very good. Now over here, we can factor out a, so it will be equal to 4. Here, factoring out an r, we are left with what remains, which is 3 plus here. Besides the r, we have 2 square root of 2 remaining. And we can easily carry this over to divide on the other side, so then we have 4r. 3. What is this here? Plus twice the square root of 2, and that's going to be fantastic. Over here we have almost what r is worth. We still need then to rationalize in order to find the minimum value of r. For that, we're going to erase all this here to write it down again. Let's erase. Okay, let's note it down. So here we apologize, we have that r will equal 4. About 3 plus 2 square root of 2. To rationalize, we need to multiply by the conjugate of these hairs. What is the conjugate? Well, we just have to change this sign to minus. We have 3 minus 2 times the square root of 2, and the same in the denominator. 3 minus 2 times the square root of 2. All of this here equals 1 because we have the same in the numerator as in the denominator. And multiplying anything by 1 doesn't change it at all. The toposenes common poposan na, kasi that is called rationalizing. Not in the numerator, I get 4 times 3 minus 2 square root of 2. Awesome! And in the denominator, I have a difference of squares. You'll remember
B
then,
the square itself, B the square.
this equals a plus b multiplied by a minus b. So this is a difference of squares we have here. A plus b times a minus b. And we can write it in that way. The first term squared. The first term is 3 squared. Would be 9. The square of the second term is 2 square root of 2 squared. So 12 squared equals 4. And the square root of 2, then the root simplifies with this 2. And it leaves us with 2.
Alright, then we're left with 2 bits.
By 4, which is 8. So then, r will equal 4 times 3, which is 12 and a half. 2 times 4, which is 8, square root of 2 over...
Sorry, but
there
that
are no
surprised
traits.
me.
Zoom in here if we want. We can leave the 1. If not, we can erase it because it's the same either way. And we have already found the radius of our small circle, of which we have to find the area. Fantastic, impressive with this. It's very simple to find the area. Let's erase this here. Alright, so we have that the area of the circle is equal to pi or radius squared. Fantastic. Then we have that the area of the circle will be equal. What's the value of p? Well, p, you know, p for now, right? And the radius, what's the radius? The radius is this right here. 12 minus 8 square root of 2. All of this here is squared because it's the radius squared. We also enclose in parentheses, and all this here will be square meters because we were talking about meters. And we said that in the end, we were going to add the units, and that's the solution to our exercise. Amazing! This setting is exactly what we were looking for in this circle right here. Take a look. Fascinating. We've already found the solution. Let me know in the comments if you liked the video, and don't forget to subscribe and hit like so you don't miss the next challenge. See you another time. Bye bye.